Then we say thanks again to Tran and continue into the sustainability assessments, and we'll be hearing about the assessment for plastics value chain done for Fredrikstad, Norway. So Alex, please go ahead.
Yes, thank you, Anna. Yes, my name is Alexander Koch. I am a consultant and researcher at Green Delta. Green Delta is mainly doing the work in the Treasures project for the sustainability assessment of the different technologies and innovations in the project. And we've developed, or we're developing, a sort of novel approach to sustainability assessments that we've termed model-based life cycle sustainability assessments, which apply system dynamics. And today I'm going to be kind of showing you a bit the build up to this work and the work we've done so far in the project on the basis of an example. And we've kind of done a test case study for the plastic value chains in Fredrikstad. And to start off, just to kind of go to the beginning again and to remind us of the definition of sustainability and sustainable development, the Brundtland Commission early on defined it as meeting the needs of the present without compromising the ability of future generations to meet their own needs. And if we think about this definition, we can think of sustainability as a system that kind of needs to be maintained. So a system that can leave its state of stability and transfer into a state of instability. And this is mainly caused by changes that are irreversible. And if we look at the kind of planetary boundaries here on this slide, we can already see that many of the impact categories that are shown here, we can see that the thresholds have already been crossed, and we're already outside of our safe operating space in terms of the planetary boundaries. And this is something we need to consider during sustainability assessments, because in the end, sustainability is about a system, a dynamic system, multidimensional system. It also covers other aspects than environment, also the social and economic aspects, as well as the resource use. So a system has multiple elements, and these multiple dimensions and elements are kind of interlinked. Next slide. And nowadays we use tools to measure these impacts, and the most common tools used today are life cycle assessment tools. For environmental environmental impacts, we use life cycle assessment. For economic impacts, we often apply life cycle costing. For social impacts, we nowadays also use a lot of social life cycle assessment approaches, and often cited formula that kind of tries to cover life cycle sustainability impacts is the sum of these three approaches. But there are several limitations to these approaches. We don't really look at the thresholds. So these planetary boundaries, for example, that I've showed previously, are not really considered. They're not, the relationships and the burden transfer amongst these dimensions is not really considered. It is, in essence, a linear approach. Furthermore, we don't really consider the context in which these impacts are taking place. So the regional setting, which often would allow us to implement more suitable solutions for those regions. Then we also often do not look at the changing conditions. So it's a very static approach. We do not consider the dynamic changes that happen over time. So often technologies change, often the electricity mixes change. And these are things that we need to consider when we're planning to implement certain solutions. And in the end, often these current assessment methods kind of lead to recommendations with limited feasibility and replicability. And the opportunities that kind of derive from this is that, we need to have a sustainability assessment that really looks at the context, the region, but also measures sustainability within thresholds, within a context such as the planetary boundaries, not always looking at the relative comparison between different technologies, but really also the absolute impact. Furthermore, we need to consider it more as a multidimensional interweaving system, and something that also considers the element of time. So looking at future scenarios, future developments, and really adapting the implemented solutions based on the changing conditions. And in essence, this will basically allow us to make more localized and dynamic decisions by considering such scenarios and the trade-offs that occur in these developments, and also make more inclusive, effective, and feasible strategy decisions. And for this, system dynamics comes in as a very good approach to conduct an assessment of a system. System dynamics, the idea behind it is that we model systems with a combination of stocks and flow rates, and these flow rates and stocks are kind of impacted or influenced by an external environment. And what we can do is really simulate results over time, so changes over time for these stocks and also these flow rates. And any system can be modeled, and the scope and level of detail is totally up to the modeler. And so we have on the slide a really easy example. So we are looking at the population of rabbits and wolves and how these two populations are interlinked. So the population of rabbits or the population of wolves is highly dependent, for example, on the rabbit density population, or the population of rabbits would be also, of course, highly dependent on the efficiency of a wolf killing a rabbit. And with these different factors that we were considering and the interlinkedness of these two systems, we can kind of simulate the population changes over time. And such an approach can also be done for a system like sustainability, or a system like a value chain, and we can measure the sustainability of that value chain within a system model. If you go to the next slide. So in the end, for sustainability modeling, we can now, with system dynamics, include boundaries. We are able to dynamically model impacts over time or changes over time, and we can conduct a multidimensional interlinked assessment approach. And this is what we've done in the Treasures project, and this is what our system dynamics model looks like right now. There's kind of a lot going on here, but if you go to the next slide, I can show you the main elements of this model. So we're looking at in the core, we're looking at the life cycle of a product, and this is really just the life cycle stages and the value chain of a product or multiple products. This is the production amounts are driven by the market. So we're linking here to a regional market, which drives the production volumes and drives the material flows along this life cycle. And of course, it is closely linked to resources, the availability of resources. So depending on how many resources available, the production volumes will of course change. And then we have the circularity aspect. So we're measuring the circularity aspects, or we're determining the circularity aspects with rates, so factors such as recycling rates, reuse rates, or even the appreciation for recycling products. So different factors will influence how well we're recycling within a specific region. And this also then determines the volumes that are going through a loop. And these volumes are then determining in the end the impacts. So, and then the impacts are shown here on the upper right corners. So we're looking at the costs, we're looking at the social well-being, and also the environmental impact, with using environmental impact factors, and also the production volumes that occur in the life cycle, in the value chain over time. If you go to the next slide, I can show you an example of what results we can get. So we've applied this model to a test case study looking at plastic value chains and different plastic products in Fredrikstad, Norway. And we basically, with the regional conditions, looking at the resources available in that region, the production capacities, the recycling capacities in that region, and also the market dynamics in that region, we could then simulate basically the development of the markets and for example, in this graph, the products that are really offered over time. So we simulated it over 45 years, and we can, for example, see that the market for LDPE at one point kind of collapses because we do, with the kind of numbers that we've inputted into the model, we do observe that resources run out because there's a high increase in demand due to a decline in the price. So we can then really see what happens when we change certain elements of the model and then react based on these negative developments and change maybe some strategies linked to this value chain in order to prevent a negative development. And the strategy decisions that we're especially looking at in the Treasures projects are the circular economy strategies. If you go to the next slide, what we're especially trying to find out is how we can improve the sustainability impacts of certain value chains. And in this case, we looked at different scenarios when considering, the circular economy strategies. Okay, what happens when we increase the recycling capacity? What happens if the recycling rates are higher due to policies that kind of force a minimum recycling rate? What changes when we have a more efficient sorting, and also what changes when we introduce certain market incentives or increase consumer awareness? And these are, we can kind of do scenario analysis in the system dynamics model, looking at these different strategies. And for Fredrikstad, we could observe that Fredrikstad already has quite a high recycling rate of plastic products, almost 80% recycling rate for plastic products. So the recycling is quite high. And then when we're considering the strategies or the solutions that we're looking at in the Treasures project, introducing, for example, a combination of mechanical and chemical recycling, Fredrikstad, might not be the most suitable region for chemical recycling because mechanical recycling is already doing such a good job at recycling plastic products at such a high rate. So this is also kind of the goal of the sustainability assessment model, is to look at the regional conditions, consider the options that are available for improving the value chains in terms of circular economy, and then making recommendations that are extremely suitable to that region and to the regional conditions. If you go to the next slide, so in summary, it's really, for one, it's possible now with this model to kind of conduct a prospective analysis. So really look at also the changes that occur over time. We can set certain boundaries. We know, the resources that are available. We know that there are certain limits to recycling capacity, certain limits to the infrastructure within a region. And then we can kind of look at different strategies that might be suitable. And this really just supports decision-making in all areas, on a business level, on a policy level. Essentially, because we're also really looking mainly at very specific regions in the Treasures project, we are really able to do a context-related or based assessment, looking at the available material flows, the available capacities, the available market demand, and make very good recommendations, or derive very good recommendations from these assessments. So yeah, thank you very much. That was my part.